Here are solutions to homework set number 8 for ECE 476. In this homework, we look at measuring your pulse with a pulse sensor and measuring temperature, pressure, humidity using a BME 280 sensor. Now, the first problem is using a heart sensor, a pulse sensor. This is what I want to get to eventually. I want to get to something where it measures my pulse and displays my beats per minute. So to do that, first I start with a program that just reads your pulse. So this is a little heart rate sensor from Amazon. You put your finger over it and it outputs a voltage, a pulse every time your heart beats, amplified a little bit. So the very first thing I want to do is, can I read that sensor? So in this case, the sensor goes to the analog input. We've got power, ground, and here's your analog input to your Pico board. That's read on the Pico as a voltage. That voltage is then displayed on the LCD display after 2 seconds. So here's kind of what that looks like. Right now it's collecting 1,000 data points, sampled every 2.5 milliseconds. Once it collects 1,000 points, it then displays it. What the buttons do is they let you try again. Collect another 1,000 data points, plot it. So there it looks like actually a pretty reasonable plot. I can see my pulse. That's really the first problem. Can I get the sensor to work? Problem 2 is once the sensor works, I want to display or calculate your beats per minute. So to do that, what I'm going to do is take the minimum, maximum, and define 2 thresholds, one at 30% and one at 70%. Set a flag. When I go above 70%, the flag is set. When I go below 30%, the flag is cleared. I'll then measure the time between rising edges. So in terms of code, here's what the code looks like. I'm going to first collect 1,000 data points every 2.5 milliseconds. The sampling rate is set by interrupts. So here's my interrupt at 2.5 milliseconds, sets a flag. Collect 1,000 data points, and then record the maximum over that 1,000 points and the minimum. I'll set my thresholds for 0.7, 70%, and 30%. Then in the code, as it goes by, I'm going to check every time I go above the 70% beyond. If the flag was 0, I'll then set it, and the time that it goes high, I'll beep. So this is when I beep. I'll turn on the buzzer for 100 milliseconds, then turn it off. If it goes below the 30% level, I'll clear the flag. So here's what that looks like. I'm not sure what just happened. So here's what that does. When I run the program, it first collects 2.5 seconds worth of data, finds the max min, finds the thresholds, and those are heartbeats. Okay, so that seems to be working. Problem number 3 then looks at, from that, calculate beats per minute. So I'm going to measure the time of the rising edge, measure the time of the last rising edge. That duration in milliseconds is your period. The beats per minute, well, this is the milliseconds between beats. So trying that, going to problem 3. I'll again run it. It collects 2.5 seconds worth of data, finds the max and min. There's the time between heartbeats. Okay, finally, problem number 4. Let's display that on the display. So I'm going to calculate the beats per minute, display on the LCD display, and repeat every time I see a rising edge, every time I see a pulse. So what that looks like, problem 4, run that puppy. there you have your pulse. Okay, so that was the first set of problems on the homework. Use your Pico to display your heartbeat. Problem number 6 is let's build a weather station. So for problem 6, what I want to do is measure temperature, pressure, and humidity using a BME 280 temperature pressure sensor. This is what the result looks like. And here's the BME 280 sensor connecting through the I2C bus on pin 0 and 1. In terms of coding, I'll just import a library BME 280, initialize the BME sensor, then read temperature, humidity, pressure, display it on the LCD display, and also on the screen, so that as it's running, I've got the readings, temperature, humidity, pressure, and also shows up on the LCD display. So at this point, I'm able to read temperature, humidity, pressure. Now that I can do that, go on to the next problem. I want to collect 1 minute's worth of data. So here I set up my data as an array and start filling it in once a second. In terms of Thani, kind of same procedure, but now I'm storing it in an array. So this is the entry I, temperature, pressure, humidity. I can read that data into an array. Now that I can do that, the last problem is let's record data for 60 seconds and then plot it. So going over to problem number 8, same procedure as before. I'm going to read temperature, humidity, pressure, repeat for 60 times. At the end, I will then display the data. Once you've collected all the data, I can then display it, switching between each of the data points. So this is the temperature for those 60 seconds. Here's the humidity. And there's the pressure. It doesn't really show off much because not a whole lot was happening over that minute. Just for fun, let's do the bonus question. The bonus was measure something, like the temperature in your car. I'm going to measure the temperature, pressure, and humidity as we go from the basement to the 3rd floor of the ECE building. I'm in the basement of the ECE building, going to measure the temperature, pressure, and humidity. So this is a BME 280 temperature, pressure, humidity sensor measuring the basement temperature, humidity, pressure, and the ECE building. 1st floor, 2nd floor, 3rd floor. When done, here's the temperature on the basement, 1st floor, 2nd floor, 3rd floor. The humidity, basement, 1st floor, 2nd floor, 3rd floor. And air pressure. So that is homework set number 8 for ECE 476.